And this is where property-based testing comes in. So you have a formula, you want to have coverage, you want to check that that formula will hold no matter what. And this is what property testing is about. You have an invariant, which is your formula, and you want to push in all sorts of inputs, and you want to make sure that the formula will still hold. And in this case, we used Quick Check and Spark. Quick Check, if you're not aware, is a tool that's open source. Anybody can use it. It's actually of Swedish origin. I believe the author is a teacher at the university here, and he had the open source version out there for a while, and then he created a commercial version which covers a bit more of the model-based testing, where you can have all sorts of randomized paths through the system. And the commercial version will take a lot of random walks through a graph, and then if it finds a bug, it will try to come up, I don't know, if it comes up with a bug after 100 steps, you don't want to give that to the developer. The commercial version will just trim it down to maybe 3 or 4 steps, so then you can debug it. In my case, in the Java world, because this is a more Erlang tool, it's a tool intended for functional languages, there's a Java port which does only randomized inputs. Moving on, this is the test. So 50 tests can be summarized with this shape. And this is Groovy, which is a scripting language over the JVM. And you have the given when then. And the most important bit is where I define the limit, where you say the trading volume plus 1. And you have the trading volume being calculated based on a formula. And this is the formula that we extracted from the story. You might need to simplify it, and maybe split it in different variations, but this is your invariant, your property. So going back to this test, if you remember, we had orders being accepted, orders being rejected, we had a size, you had a buy, you had a sell, and this is all done for you. In this case, this only works for the accepted side, and you can see how the rejected side would be easily derived. And you can see that the trading volume there, I add 1. And then when I'm setting my limit, I'm setting it with that trading volume plus 1, and then when I'm placing the order and then checking the assertion, I'm making sure that that order got accepted. If the order wasn't accepted, the assertion would fail. There would be no limit usage. So that basically means a failed test. If I had trading volume minus 1, then I would expect those to be rejected, and the assertion changes a bit. This basically took us a month of trial and error, so don't expect this to just be applied overnight. In the where clause, and this is all Spark, the fact that you have a where clause, I mean, even the given when then is it's Spark, which is a unit test framework, which has a mocking framework and also a runner to run these sort of tests. And you can see in the where clause, where I define my instruments, I'm basically defining a list of instruments. And each call to that list, the list will be composed of 200 components, all randomized, and I'll show you in a bit what I've randomized. But you get 200 tests that will have random input, and let's go a bit further, and I can show you what quick check does for you in this case. So we covered Spark and property-based testing, and this is quick check. This is how you build up an object to be in your list. And you can, once you've defined your object, you can basically define all sorts of random values. I actually grabbed the configuration of our instruments from production, so I can tell which are the valid ranges. You can also put in invalid ranges if you want. That's another type of testing that you can do. And quick check gives you that power. It gives you the power of defining integers. You can even define, when you want to populate a field on an object, you can use your own objects as well. And once I got to use this and plug it into this one, I had something that looked like this. And this is all randomly done. You can see the currencies. You can see the initial bid price and the initial ask price. They're all to 5 digits or 3 digits, and it's all down to how that initial list of inputs gets generated. So, my conclusions from using property-based testing with Spark and quick check, it can't necessarily be applied to all sorts of tests. And you have to be careful which stories you are going to apply this to. If you're not given a formula, then you're out of luck. You also need to model it. First of all, you need to understand what you're testing, in the sense that it might be so complex, the formula, that you might want to run some simulations of your own. I don't know, I've used Excel for instance. So you model it, you run the testing in Spark, and you see the outcome. And if it's not matching your expectations that you've done by hand, then you might be going off. And I had a lot of trial and error where my model was encoded incorrectly. I had a model, I had it from the business analyst in Excel with a lot of simulations. So I had to code up the model in Spark. And you'll definitely get coverage. You'll get a lot of free coverage, in the sense that the 200 tests that Spark and quick check create for you can be increased to even 1,000. And once you run with a lot of iterations, with a lot of randomized input, you might find corner cases that are quite interesting. And another, for the future, once you have this in place, you can definitely go to model-based testing, where you can define your state machine. You can define states and transitions between states. And each time you enter a state, you can give quick check, you can tell quick check to generate the data for you, and then you can have your assertions on that state being the invariant that you've chosen. So each time you transition to that state, you check that, is my formula still holding?